Hi folks, Chris McClure here. We are now done with chapter 1, and we will move to chapter 2, starting with section 2.1. Going to re-familiarize you with the two-dimensional coordinate system, sometimes called the Cartesian coordinate system or the rectangular coordinate system. Here we've got both the x-axis, which is a real number line, at right angles with the y-axis, which is another real number line, and those two axes cross each other at 0 on their respective coordinate systems. And at that crossing of the two axes is what we call the origin. We can locate any point on the plane by locating how far it is horizontally relative to the origin, and that will be the first coordinate, and then vertically relative to the origin, and that would be the y-coordinate. You'll go up for a positive distance vertically, or to the right for a positive distance horizontally, and then left and down for negative. If you want to plot the point 6, 4, well, that's going to be this point because it's 6 units to the right and 4 units up. If you wanted to plot the point in -3, -5, well, then it's going to be, 3 units to the left and 5 units down to be at this point. So remember, it's this first coordinate here that tells you how many units to go horizontally. In this case, -3 means that you go 3 units to the left. And the second coordinate tells you how many units to go vertically. -5 means you go down 5 units. Well, the point 0, 7 is going to be right here because there's 0 units horizontally, but 7 units up. So you're right on the y-axis there. The point -6, 0, -6, 0 means that you're going to go 6 units to the left and 0 units up or down. Okay? So now that we've refreshed ourselves how to locate points on the plane, let's remember also that the x and y axes divide the plane into 4 quadrants, starting with the first quadrant in which all the points have x and y coordinates that are both positive. And then moving to the counterclockwise direction, we have the second quadrant in which the points have negative x coordinates and the y coordinates are positive. So the x coordinates are negative, y coordinates are positive. And then the third quadrant down here to the lower left, all the points have negative x coordinates and negative y coordinates. And then finally to the lower right, we have the fourth quadrant in which all the points have positive x coordinates and negative y coordinates. Now we're going to talk about how to compute straight line distance between 2 points on the plane by using the so-called distance formula. And you're going to see that this distance is measured by using an application of the Pythagorean theorem. So suppose we want to, for our example, compute the distance between the point 1, 3 and 5, 6. What is that straight line distance? Well, what we could do is imagine that we have this right triangle in which we have 4 units horizontally and 3 units vertically between those 2 points. And then we could say, well, this straight line distance d, well, that line segment is the hypotenuse of the right triangle, so we can say that that distance d is going to be the square root of 3 squared plus 4 squared, so the square root of 25, which is 5. So 5 is going to be the distance between those 2 points. And generally speaking, if you have one point, call it P1, with coordinates x1, y1, and some other point P2 with coordinates x2, y2, then the distance between those 2 points, which we denote as d parenthesis P1, P2, like this, the distance between P1 and P2 is calculated as the square root of the sum of the squares of the differences between the x-coordinates and the y-coordinates, like you see here. So you just subtract the x-coordinates and square that difference, and take the difference of the y-coordinates and square that difference, and then add those differences squared together, and then take the square root. And here's the picture here. Here's P1 here, and here's P2 here. Here's the right triangle where you have a horizontal leg with a distance or a length of the difference of the x-coordinates, x2 minus x1, and this vertical piece right here with the distance or a length of the difference of the y-coordinates of the 2 points. And then using the Pythagorean theorem, you can just say that the distance between the 2 points is going to be, the square root of those, difference in the x-coordinate squared plus the difference in the y-coordinate squared, like you see here. And if, your points have the same y-coordinate, then all you need to do is take the difference of the x-coordinates. And if your 2 points have the same x-coordinate, then the distance between them will be the difference in the y-coordinates. Suppose that we want to find the distance between these 2 points here. Well, then you're going to just take the difference between the x-coordinates. So you can do -1 minus 2, which is going to be -3 squared, and then also 3 minus -4, which is going to be 7 squared as well. And so you'll have, square root of 9 plus 49, which is square root of 58. And you know what? You don't necessarily have to make a decimal approximation. You could just leave it as an exact number, square root of 58. But if you want to do an approximation, that's fine. You can put it in your calculator and evaluate square root of 58, approximately 7.62. Be aware that when you are using My Math Lab to do your homework, the system will tell you how to input your answer. Make sure that you are paying attention to how many decimal places, or as to whether it wants an exact answer or whatever. Here's another application of using the distance formula. Suppose that we've got three points. A is -2, 1, B is at 2, 3, and C is at 3, 1. So we have 3 points on the plane, and those 3 points will form the vertices of a triangle, like you see here. So we've plotted these 3 points. A is at -2, 1 right here, and B is over here at 2, 3, and C is over here at 3, 1. So now we're going to find the length of each side of the triangle. So we're going to use the distance formula 3 times. There's the distance between A and B here. And as you can see here, that works out to be 2 times the square root of 5. I'll let you check those details yourself. And then we're going to calculate the distance between points B and C. And again, check the details yourself, but that works out to be square root of 5. And then calculate the distance between points A and C for this line segment right here. And that distance works out to be 5, as you can see from this calculation. Then the question is this a right triangle? In order for it to be a right triangle, the Pythagorean theorem has to hold. That basically says that this leg length squared plus this leg length squared must be equal to the hypotenuse leg squared. So we can go ahead and try that out on your Pythagorean theorem. So this length between A and B was 2 root 5. So we'll have 2 root 5 squared, which is going to be, 20. And then here we've got the distance between B and C, which is root 5. Square that, you get 5. 20 plus 5 is 25. But then the distance between A and C is 5, and 5 squared is 25. So we really do have the Pythagorean theorem holding true. So that verifies that this triangle really is a right triangle because the Pythagorean theorem holds for those three sides. If we wanted to answer the question, what is the area of the triangle? Remember that the area of a triangle is 1/2 times the base times the height. So you could just simply, take, one side, the longer leg as the base, and you can take the other leg to be the height. Now, I'm not talking about the hypotenuse. Don't use the hypotenuse. Just use the two legs, which are the two shorter sides, and then times 1/2. And there works out to be 5. As in, the area of that triangle is 5 square units. Now, the midpoint formula talks about finding the coordinates of the point that is exactly halfway between 2 points. So suppose that we have point P1 at coordinates x1, y1, and P2 is at x2, y2. Now, what are the coordinates of this point? Let's call it M, with coordinates x, y. What are x and what are y? Or what is x, what is y? So in order for this point to be exactly midway between P1 and P2, we need for the x-coordinate to be the average of the x-coordinates of P1 and P2. And likewise, we need the y-coordinate of M to be the average of y1 and y2. So if we wanted to develop the formula for x and for y, what we need is the displacement between x and x1 to be the same thing as the displacement between x1 or between x and x2. So we need this horizontal distance to be the same thing as this horizontal distance. That's what this equation is saying. And then you could just simply solve for x using a little bit of algebra. And then the same thing for the y coordinates. That says that this point y will be exactly halfway between, this y-coordinate and this y-coordinate up here. In other words, the difference between y and y1 will be the same thing as the difference between y2 and y. And then simply solve for y using algebra. So you could see that x and y are respective averages of the x and y coordinates of the points. So that tells us if you know the coordinates of your 2 points, P1 and P2, then this right here will tell you how to calculate the coordinates of the point that's midway in between. In other words, it's the midpoint. So here's an example here. Suppose that we have a point P1 with coordinates 4, -2, and a second point coordinates 2, -5. What are the points plotted on the grid? And we're going to also plot the midpoint. Now, to find the midpoint, we take the average of the x-coordinates. 2 plus 4 is 6. 6 divided by 2 is 3. So the x-coordinate of the midpoint is going to be 3. Same calculation for y. You take the average of the y-coordinates, -2 plus -5, which is -7, divided by 2 is -7/2. So 3, -7/2 will be the coordinates of the midpoint. We're going to go ahead and plot those points, all 3 points. Here's P1 at 4, -2, 4 minus 2, and then here's P2 at 2, -5, and then the midpoint is at 3, -7, 2. So here's x-coordinate 3, y-coordinate -3.5, which is -7/2. Okay? So now we know how to find the midpoint between 2 points. So on this block, we talked about how to find the distance between 2 points on the plane, and also how to find the midpoint. Okay, so that's it for today. We will cover section 2.2 next time. Have a good day.